How a seismograph works. A seismograph is an instrument used to measure the movement of earthquakes. A weight is suspended in a way that allows it to remain still when the ground moves. Most modern instruments use an electromagnetic mechanism for this. A writing instrument is attached to the weight, allowing it to record the movement as it happens. The word graph refers to the writing action. Most modern earthquake monitoring uses seismometers, not seismographs, and record the movement of the earth digitally, or output the data to a seismogram, a printed version of the wavelengths on a large drum. These wavelengths that represent Earth's movements are so small that in order for scientists to study them, they have to be amplified.
Earthquake strength is measured in two ways: magnitude and intensity. Magnitude is a measure of the energy released at the earthquake's source. But how do scientists measure this? A network of sensors called seismometers is used to record earthquakes. An earthquake's magnitude is calculated based on the ground motion recorded by each seismometer and the distance of that seismometer from the earthquake. For each unit of increase in magnitude, the amount of ground motion increases by a factor of 10. This means the amount of ground motion for a magnitude 6 earthquake is 10 times greater than for a magnitude 5, and 100 times greater than for a magnitude 4. Intensity represents the strength of shaking we feel. It depends not only on the magnitude of the earthquake, but also our distance from the epicenter, and whether we are in a building or outside. The underlying geology also affects intensity. People on soft soils usually experience longer and greater shaking than those on bedrock or stiff soils. Remember, magnitude equals energy released at the source. Intensity equals strength of shaking that we feel.